A warm welcome to our next speaker, Martyn Kilbryde.
Thank you, and good afternoon. It's been a long day. So, ChemistView, if you've never heard of us, we've been around, like I said, about 2011 when it was founded. So it's online-only pharmacy. So you might have heard of a few of these. We're in the top sort of 3 in the UK, and it's actually more than 175,000 items per month at the moment. But there's the website where you can go online and you can buy over-the-counter medication and that sort of thing. But there's also the kind of NHS side where you can nominate us as your pharmacy, go to the doctor, and then it'll get posted out to you. Or if you've got every month, it'll just arrive at your door if you've got a repeat. But we also do prescriptions and stuff on behalf of third parties as well. So the journey I'm talking about now is this new partnership was formed with this company called ADHD 360, which it's like a private ADHD diagnostic treatment clinic. So obviously it's been in the news a lot. There's like the NHS struggles with trying to help people with ADHD. So these kind of clinics, you can go through the NHS. There's like different pathways through these clinics, like Right to Choose it's called, but also you can pay to go through there to get assessments. And if they decide that you need medication, then we were to be the dispensing pharmacy for that. And so as they would literally just write the prescription and send it to us, basically. Now, for this to work, we obviously need this kind of secure integration. So when they prescribe when they do a prescription for some medication, that needs to be sent to us with the patient details and enough of the information that our clinicians can do a check on that. It's not just a matter of we receive it and just send some medication in the post, but we have pharmacists and clinicians and so on who do the checks. And we also need to take the payment for that if it's not NHS. So if you pay for your medication, then you're buying the medication from us, basically. So we take that money. So we need, depending on the calculations, because the NHS is quite tricky, but if it's non-NHS, it's a bit simpler. But we just calculate the amount of money, and then we need to take it from you, credit cards, and so on. And then that kind of clinical check side needs to happen, which with the ADHD drugs, there's like control drugs there. So there's actually quite a lot of process you need to follow. So you need to go through our clinical checks in the background. We have people checking these medications, and there's lots of business rules around that need to be built into this to make sure it's safe for patients. And also because we're taking the payments and they're coming to us, obviously customers need to be able to ring up, they need to be able to contact us. There's going to be issues that come about, and so there needs to be some kind of portal where people can log in, our customer service can log in and help and track these kind of prescriptions. And we've got an existing warehouse fulfillment system. Now we've actually just in the process of moving to a bigger warehouse, and there's robots there which will do the dispensing and so on. So we need to integrate with that existing system that we use for the NHS and so on. But also it needed to launch in 8 weeks. And that was driven based on the ADHD's previous partner was struggling to sort of get hold of medication and so on. And we've got quite a lot of medication in stock. We're quite a big provider. So the deadline kind of came from we need to get to the point where we can, patients aren't going to run out of medication. And we believe we could do this in 8 weeks without crunch. I'm Martyn Kilbryde, so I'm head of engineering at ChemistView. I've been there full time for about 6 months now, but I've been working with ChemistView for about 18 months overall. So because we've only got 8 weeks, the biggest thing that we need to do is concentrate on the business logic. We're not going to have much time. As a company, we have some kind of infrastructure like EC2 and so on, but we don't have a big infrastructure team. So because we just want to concentrate on business logic, that's why we went for serverless. It's something that we've got several years experience in. We've got serverless elsewhere in the business. So for this project, it doesn't make sense. And that just gives us that built-in high availability, which is something you still need to think about with serverless. You don't magically get high availability. But by default, you do get a very good amount of high availability. And obviously, you can design around that correctly. And it's just really quick to get going and not have to think about too much. Same with administration. So there's like really low administration when you have it set up correct, because you're not managing servers, you don't need ops teams and so on. The scaling of this is, it's interesting because we don't have a website, like a public website where you can hit it from Google. Like people will log on to this portal and we'll receive prescriptions from the partner. So we're not going to need to do hyperscale. But we do obviously want to benefit from the fact that nobody's really logging on to pay for medication at 2 in the morning. And so scale to 0 and having really simple scaling that just built in that we don't really have to think about works really well. And obviously rapid development is just like really important when you've only got 8 weeks, and that's what serverless, especially when you've already got the knowledge and a lot of the base resources, like we've got CDK knowledge and so on. That's what we get. So with a lot of these types of projects, the best way I've always found to get going is, start with this really simple prototype, not a proof of concept, but like an actual prototype that will turn into the deployable product. So it should be working end to end. It should have all the fundamentals, but it's just missing like that kind of business logic that's needed to make it actually the end product. And so that means we've got that CDK project in place where we can deploy out to the environment and we can have our resources. We've got linting from day one so that we're not writing loads of code and having to revisit it later. Like we want it so from day one, everyone's got the same thing, baseline to start from. Same with unit tests, you want them from day one if possible. And then, as you build this brand new code base, you're covering it in tests and you don't have to spend a lot of time later on trying to go back and fix bugs and so on. And a hexagonal architecture in the kind of Lambda functions was used as well. Now, I'm not going to get into too much detail about that if you've never heard of it, but for the most part, it's just a matter of having an architecture in the Lambda functions that means we can extend. So you can imagine that you might want to start off with a stub repository, and then later on you might want to put a Dynamo repository in there. And you don't want to put everything into the handler from day one. So if you get the basics of that in place, just the different elements of a hexagonal architecture, then you can start to extend it with multiple people without stepping on each other's toes and getting loads of clashes in source control. So day one, we just want to start this. We can initialize the app CDK, which is really easy to get going, and that'll give you this base project, which you can actually immediately deploy into your account. It won't really deploy anything, but obviously you've got the base project there. You've got your jest set up. You've got the ability to add your tests and so on. And then the next step of that is we're going to have this patient portal that I mentioned, like an admin portal. We've got these websites that we need to deploy. So we can quite quickly, using Vite, just build out a full React, in this case, TypeScript. This is the patient portal, but we actually built 2 of these, which has got the app and so on. And obviously, if you've ever seen a React app when you've started it, you just have this base page that you can click on. And then that just needs linking together. So we've now got the front ends, we've got the CDK. We can quite quickly put together the different elements. So in this case, it's a very simple example, but just a bucket deployment with CloudFront in front of that, and a REST API for our back and forth between the front end and the back end. So with all that put together, obviously a lot of it's boilerplate. In a few hours, you get this basic authenticated website, because we've just got Cognito, and just put Cognito on that API with CDK really quickly. And the API is stubbed, which I'll get into a little bit more in a bit. But you've now got this kind of working API that's authenticated from the front end. You've got the ability with unit tests and linting. Like I said, there's no real unit testing at this point, but the point is the framework's in place, and linting is running from day one. And then we've also got CI/CD in there. So we can copy our CI/CD pipelines from elsewhere and kind of mirror it. So it's quite easy. But and especially what's important with this is the kind of ephemeral environment idea. And this is one of the reasons that serverless is just so powerful. Because what you can do then is every developer, let's say you've got 4 developers, they all just run and create their own environment in the same account. So everyone can get going really, really quickly. And then when you're finished, just do a destroy of that. So again, once you've got this base started, this is now day 2, what's the most complex area of this system? That's where you want to start. We've only got 8 weeks. You don't want to start off trying to make the website really pretty, and then in 7 weeks you realize, okay, I've got to do, this super complicated integration, basically. So the integration is literally the most important part of this to get working. We've got to accept this data, we've got to do really good validation, and then that's what's going to form an order that we end up picking and shipping out to the customer. So it's really important just to define that interface like as early as possible, because the third party we're working with, they've also got developers and they need to do their own development to integrate with us. So they need to get going as soon as possible as well. So we deploy this basic stubbed API, which has got no functionality in it, but it's acting just like production will. So it's got the validation in there, so they can hit against it, they can do the coding against it, and they're getting the responses that they will get, but under the hood, it's actually not really doing anything. And also just maintaining the shared environment, and we'll put like a living Swagger document there. So it's a documented shared environment that they have access to. And so within that first week, they could be up and running, hitting this API, and with a documentation there. And it means you can work together, because there's obviously going to be problems in that up front. We've got an idea of the type of information we need, such as patient name and so on. But they've also got information in their system that they might think we need. So we have to work together to come up with that interface, and we can do that in a stub way where we don't have to worry about what's going to happen later in the line. Now, if you are creating API Gateway, you can use stub responses directly in API Gateway. So that can get you going really quick. And also, you've got built-in validation in API Gateway. And that, again, if you define it, it's quite small text, but you don't really need to know the detail of it. This is just showing you in CDK how you define the schema. So we just, in this case, it's a very simple version of just the customer name and address, min lengths, and sort of types, and so on, and which are required fields. So you can put that into your endpoint, and it will reject if we receive it. So let's say we get a post to our prescription endpoint with the customer name of test, for example, but it's not got the customer address in there. API Gateway will return an error message. It'll fail out of a 400, which is good, like it's being failed, but the main issue with this is obviously if you're a developer, put your head into the person doing the integration, that doesn't really tell you much. You get invalid request body, you would go to the Swagger document, you would compare what you sent to the Swagger document and try and figure out what's invalid. So obviously it's a lot more useful to send back why it failed. Now in API Gateway, you can set this type up, and in the bad request body response type, you can set it up to have this template where you return the validation error as a string. So this is a really sort of quick way of just returning that information to them. So in that same example, we now can see, even though it's JSON formatted and so on, that customer address is missing. And suddenly we've got an API which is a lot more useful. But if anyone's ever done this, then you'll get to the point where something like this, as an example, you're posting to the endpoint, got customer name and street, but some of these are empty strings. So it will fail validation, but it'll give them a very basic string that says that it's too short. But what's too short? Like, is it the name? Is it the street? You can imagine when you've got 100, 200 fields, that actually that's not particularly useful error message. And so we went further than that, and we used Zod in the actual Lambda function itself to do our validation. And if anyone's used like Power Tools, the parser in there also uses Zod under the hood. So in this case, you've got a lot more power. So in this example, if you can see it anyway on the screens, we've got the ability to have min and max like before, but you can also check, like you can run regexes if you want to. You can do a lot more power in there about what's optional. And more specifically, you can put messages, the exact message you want to return, so people know exactly why it's failing validation. And the power in Zod is really good if you need to do this type of validation. Now, returning the error back, you get this JavaScript object effectively of what the failures are. So in a very simple way, again, we just, in the first couple of weeks, we just flatten them errors and just return them as a big JSON string. So you end up with this ability to see exactly what failed. It's not the best because it's a JSON formatted thing, but it's telling them exactly what they need. And again, we're moving quick, so we can revisit this later. And we just assume this would be used for debugging because they'll see the error message whilst they're doing their development, and they'll make the fix and so on. But actually what they ended up doing was parsing that and then displaying the specific reason it failed in their UI, which is actually ends up being really good in the fact that their clinicians can see, oh, I've not put the person's last name in their system. But what it means is that now we can't change that interface. The interface is now set in stone, and if we want to change it, we'd have to try and do it in a backwards compatible way and work with them. And that's why doing that integration up front is so important, but also you've got to be really careful because they will build against what they get, and that's what we gave them. And like I mentioned before, if you are using Power Tools, in this case it's MIDI, so at the bottom here, we can use the parser from Power Tools and specify the schema, and in this case I've got safe parse is true, which means instead of just rejecting it, it will actually still execute up here into the handler, but it'll pass in the type, and as you can see in this very simple example, you can then check if it was a success or not and return a specific error. If you don't have safe parse set, it'll just reject it, which is fine, but you don't get like a nice error message. You can't log basically and so on as much. So the other problem is that obviously in this case, like I mentioned at the start, is they need to be able to manage their orders. Like the patients need to be able to log in and pay effectively, like update their delivery address maybe. And obviously to do that, we need to authenticate the patients to allow them to log in. Now, ADHD 360 themselves have this patient portal. So if anyone logs into that portal, they can book an appointment and so on. So you don't really want them to have to log into that portal, but look at, oh, here's my medication and so on, and then have to go and log into a separate portal to then go and pay, for example. Now that is one option. So basically we receive that prescription, and what we do is we create them an account, send them an email, they click it, they set up a password, they've now got 2 accounts. And if you've got Cognito, that's actually a really easy process to do. Now the other option is that we actually do build this kind of custom single sign-on. They've got their own specific bespoke kind of authentication provider, and that way the patients can log in with the same credentials, or they can follow a link, and it just all works. So the downside to this first one is it's just a poor user experience. Everyone forgets passwords or tries to keep the passwords the same. There'll be a lot of people trying to log in to our portal with the same password in their portal, and it won't work and so on. But if we go down this route, it's actually really complex, and there's no way we're going to get that done in 8 weeks. It'll actually be, many months of work potentially. So we ended up going for passwordless authentication to get in. Now, if you're doing passwordless authentication, there are a few different options here. So they enter their email or phone number and get a code. You can also do a magic link, so they type in their email and get this magic link that they click on. Very similar, but the downside to a magic link is that they have to be on the same device. So if they're on their work computer, they'll get an email on their phone, and when they click the link, they're not, it's a different device. So potentially it's a problem. And ideally, passkeys and FIDO2 capable stuff you can use as passwordless as well, but in that case, you need to be authenticated in the first place to set up that. So it's not something we can use in this scenario. So we went for the one-time use code because it was the simplest option. And Cognito's actually got some good capabilities around building this in. It is kind of custom, but that's why it has this ability of being able to have custom challenge flows. This is a very simplified version of it, but the AWS documentation is pretty good, and there's some good blogs out there for if you actually want to do this. But effectively, you have these 3 different triggers. So the first time somebody tries to types in an email and tries to authenticate with Cognito, it needs to hit this define auth challenge function, which just returns, please do one-time passcode, because that's what we're doing every time. Then it'll hit another Lambda where we need to generate that code and email it to them, so we can send it through SES in this case. And then if they type in the code, we just need to verify that. So it's actually relatively simple to get going. So we got that up and running in the first few weeks without too much issue. The only issue we had with that one is that you have to get that email. And so the first couple of weeks after we went live, we started to get quite a lot of problems. Patients not receiving that passcode, they couldn't log in. And there's a few reasons for that in the end that we managed to figure out. Anyone who's worked with email knows it can be a problem, especially when you start designing your emails and putting images in there and having HTML basically. But it's just important, what we found was like the domain basically. So when you're hosting your images, whether you've got links in that email, make sure the email address it's coming from, make sure it all matches. And then at least it doesn't look like it's phishing. And the actual email address itself, in this case, it wasn't an issue because of where we're emailing from. But if you follow the link, it'll take you through to a government page where you can check your email domain. But making sure you've set up, like DKIM in this case, but setting up email security so that like Gmail will actually validate that email is coming from you and it's not phishing, and it just helps things flow into the inbox a lot better. Now, we also need to build this full customer-facing website, like I touched on earlier. At this point, we've got this really basic React template, which is set up, which has the ability, if we write some code, to call the API, but it's not doing much. Now, again, we're working on a tight deadline, but also we don't need to have too much functionality up front. We need to be able to log in and pay. We don't need to have too much. So we just need to use that technology that we already have that expertise for. So we want to be using off-the-shelf component libraries, templates, and so on. We just want to stick to the basics of, say, React. We don't want to be going back and forth on like pixel perfect design, which can take a long time. Just stick some colors basically in there. So we using React, it's something that we're already using elsewhere. Our native app is React Native, so it just makes sense to stick with React for the front end. And in this case, we use Chakra UI for the component library, which if you've used before, you can like drag and drop all these kind of things on basically. It's quite easy just to install them into React, and you can get running quite quickly and having your tables, your message boxes, and so on, and build up this website. Stick some color coding in there effectively in the config, and you end up with a page which looks just like our site. It's got the right colors, and we can put a logo at the top, and it's really quick to get up and running. Now, right at the start, I said about deploying this, we were deploying it to S3 with CloudFront in front, and now you've got this website. We can put a custom domain on there, and people can browse to the site. And then when they need to make a call in the JavaScript, which is from the browser, it makes a call through to API Gateway. Now, the only downside we had with this one, and anyone who's worked with doing this sort of thing, is you will get cause errors. Which is really, really painful. So the easiest way for us to solve that was we just moved it behind CloudFront. So it's just on its own path. It's all under the same domain. We don't have to worry about cause. And it has other benefits because it's a single URL, single domain. Now, one of the things I touched at the start is these kind of flows for a prescription. Like you've got all these various flows of how, like, depending on where it's coming from, like is it an NHS one, is it a private prescription? Have they been with us before? Is it the first time it's coming to us? That kind of thing. So we've got these different flows that we've got to do. And so we went with step functions for doing workflows because obviously that's kind of what it's meant to do, but it gave us quite a few benefits here because we can asynchronously process these orders as they come into API Gateway. So effectively we can take it from API Gateway, and we've got the Lambda in the middle for doing that validation, like I touched on earlier, but effectively just push it into step functions. And then this is a really, really simplified version of a step function, but we can go through the flow of directly hitting Cognito to say, does this person have an account? If they don't, we'll create that account. We'll create them in DynamoDB. If they do, we can just sort of update their details in DynamoDB in case their address has changed or so on. And then we can insert the order into our database, And we can have some logic at the bottom, like are they exempt from paying? Because if they are, then we don't need to do much. But if they aren't exempt, we need to send an email to say, please come on and pay. So we can just immediately push that into a queue, process it to send them an email asking them to come and pay. Now, because we're in step functions, then we want to start actually handling, well, what if these fail? What if Cognito doesn't create a user and so on? So because using step functions, we can add in error handling quite simply, and we can catch the errors. Now, at first, what we did is mostly caught the errors and kind of put a record in a database so we could have a UI so we could see what's failed and put in some alerting and so on. But obviously, there's specifics around some of these where we might have retries and so on. And then we can just extend it. So in this case, we can change it. So we've got another order type. So, like I say, NHS or private and so on. So we can have different flows depending on the type of order. We can call different Lambda functions or the same Lambda function with different inputs. And yeah, we can, we're up to many versions of this at this point, obviously, for the different types of order that we get. Now, I touched on about errors. One of the things with this is when we went live is we're going to get all these prescriptions coming in. But what if the prescriptions have problems? We can send, we can look at logs and so on, but it doesn't really make sense. So one of the things we use elsewhere is using AWS Chatbot. So we put that in place quite quickly on this. And it was specifically not just like throwing errors in there, like alarms, which are really good, but more along the lines of, say, if validation failed, we can put a message in there which gives you the ID and it tells you why it failed. And so it's not technical stuff you need to look at that. It's more operational stuff. We don't want to build this system where suddenly we have to pay developers who are going to cost a lot of money to sit and look at alerts, which aren't actually technical problems. So in this way, we can sort of have different channels in Slack potentially. And it's, just flag it up really quickly and give them the information that they need. And AWS Chatbot, if you've ever done the integration yourself, it's got a lot of power in terms of the schema. So in this case, we're printing like the exact error message just as JSON, but we've got like little tags in there and so on. So it can be really useful for sort of sorting these things out. But I mean, the main problem overall is 8 weeks isn't very long. So ultimately, we had this small team when I started. We built up a few people at the start, but we had 4 engineers working on this, 1 person testing it, and we had a product owner sat in the squad to build it up. So 1 squad just aligned, and this was the only work they were working on for that time. We had a really lean software development lifecycle on it as well. So it's a very basic Kanban system, really, effectively. So everything's small and deployable. So backwards compatibility is not quite an issue at this stage because it's the first 8 weeks. We're not really in production apart from that interface with a third party. But it's a process that we're still running to this day. And you try and get them tasks down to like 1-day tasks, basically. So break things down. Things are always flowing. The general rule is that we're progressing through. So if you're creating something that is going to cause some tech debt, that is actually fine as long as you create a ticket to fix the tech debt later, potentially. Like we don't want people sitting there for 2, 3, 4 days working on a task. We want things constantly flowing. And like I mentioned earlier about linting, like having linting prettier biome, doing it all, something like that from day one, because we don't want people sitting in code reviews getting hung up on simple stuff. Like it's one of my biggest pet peeves is people sitting there and talking over and over again in a PR about spacing or something stupid. Like it doesn't matter as long as the code's working and it's not nonsense. Like it's fine to have them opinions, but you might as well just get automation to do it. So especially in this first 8 weeks, but even then we've carried that on. I'm always on about focus on high value and good enough, but that doesn't mean don't fix it later. Like I say, it just means you keep shifting that code, but you always just like have that ownership that people go, yeah, this works. I want this one could be a little bit better. Raise a task, we'll get to it. Like it's fine, depending on the task and so on. So after that 8 weeks that we did at the start of the year, like was it done? Well, it was obviously just an MVP, like we're talking about here. Considering it was an MVP though, like tech debt was actually really low considering. Like since then, development has carried on, same squad. We've actually got a few more people in that squad. But most of that has been, it's not been like going back and fixing. It's been adding new features. It's been extending it so we can work with more partners. It's continuing development of it. It just needs continuous improvement. And one of the things I like to say with these sort of things is like, if I look at that code base next year and it looks similar to the code that we wrote this year, in a way we've sort of failed. Like I want it to keep moving, like it's a moving thing. And yeah, so tech debt just kind of disappears quite quickly if you've got that model. The other thing is just around data quality and integration. Like I've said before, that integration is like really key. But they're sending data from their system into ours. And if anyone's ever had like multiple different systems, you'll have the same data in multiple different places, it can get really messy. Obviously, ideally, you want a single place where all the data is. But in this case, we've got two companies, so it's a bit different. And then also, you're like, what if you need to update that data? So they make a change. Now we've got that data stored in our system, potentially in a few places, because we've got, it might be in the warehouse, and they've got their own systems or so on. So you need to start, that's one of the things we have to really start thinking about is how do we keep that data clean all the way through? And just spotting minor issues when you've got this kind of high volume of data is actually really hard. Like it's, like a silly example might be that the names are coming through with a space on the end. Nobody can see that. Like you can't see that in the interface. But at some point that might cause a problem. So how do you spot them little things? And so, yeah, ultimately, it's just been a continuous process where we've been, adding better observability and so on. And that's kind of what's helping us spot these kind of issues effectively. And like when we went live, we had, basic observability. So we use Power Tools, like I mentioned before. So we've got sort of structured logs. We didn't have X-ray at first, but that clean structured logging meant that at least when we went live, we could quite quickly like debug issues and so on. But yeah, we added tracing later, and the idea is to move to these more observability sort of things. If you sit in here and watch the next talk, you'll find out a lot more about that, just to be able to trace these through. And this becomes really important for the next sort of stage of this system is, across the board, we're moving towards EDA and DDD in a lot of our systems. So, the back end of our app is moving towards that. This system also needs to go into that. The whole company is going into the same, we want the same back-end services. We don't have multiple ones. So like, as an example, payments, when we did payments for this, we just needed a very quick payment integration to take some of these credit card details. And so we built in a really simple webhook handler, and payments was built into this application just because of the time constraints, because where we take payments elsewhere, we didn't have the time to refactor to make that work across multiple systems. And so the plan is, we're going to continue splitting out these self-contained services across all our systems, so it'll be the same sort of domain. And yeah, hopefully we'll end up with something more similar to this. And this is really just a very quick snapshot, just because it's not the talk to start getting into the details, but effectively where we've got product service, order service, patient service, all driven by event buses and that kind of experience layer at the top of the different inputs. So the patient portal that I've just mentioned, our main website, the native app, and all these different integrations will all just feed into this set of services in our domain layer. And yeah, if you go through to the QR code, there's a really good post from Lee Gilmore just talking about this kind of exact model. But yeah, thank you. If you obviously grab me afterwards or ask some questions now if you want to.
Thank you, Martyn. So I'll open the floor for some questions. We'll scan around the room. Hiya. I'm going to bring up Gen AI. Did you use any sort of code gen tools to get you going early on, or was it not thought about?
So I use Copilot. And so a lot of some of the early stuff around CDK would have been using Copilot. It wasn't a conscious thing to try and get going too much. It's more just it helps you out, get going. In a lot of cases, because we've got these patterns elsewhere, we could kind of copy paste code in from ourselves. But yeah, definitely it was in there and helping.
Hi, Martin. You mentioned hexagonal architecture you used. Is it utilized to improve serialization of data for Lambda invocation?
So it was just effectively our way of splitting in the, so we've got, I can't remember how many Lambdas we ended up with, let's say we've got like 20 Lambda functions, but we've got a patient repository, we've got the patient data, so it was just the way we split it up so that we could have the patient service, the patient repository, the different ways where we can have common code between the important handlers, but it's split up into their own little domain areas so that we can take that patient area and split it out into its own service in the future. That makes sense?
Okay, well, thanks again, Martyn.
No problem.